now they want. All right, here we go. So did you say weight?
No, saying weight.
Oh, okay. All right, let's take a look. That would be a great extra credit question. Second test. Remember, this is second test material now. I know you're like, oh boy, I gotta do all these things. Great.
Are we adding more to the
No, we're done. We're done. So now, we're going to spend the rest of our time today taking a look at the equation itself. So now what we want to do is, let's see, we're going to study and solve this equation. I don't even need to write this equation. Study and solve. Let's just write the equation. The equation is m y double prime plus k times y equals 0. Okay. Right off the bat, it equals 0, so our solution would represent what? Yeah, this is going to be our null solution. So really what we're finding here is a null solution. Okay? So that's our first order of business. And I think this solution might surprise you. I hope it does. It surprises me every time I do it. But we could guess for a bit, but in the spirit of what we've done, let's just try E and see what happens. Let's just try E. Because remember, we said originally before we started this class, we said, well, E represents exponential growth. But then we looked into E a little bit deeper, and we said that E can also represent what? Yeah, circular motion. If you have what? The complex field, right? The complex field. So let's just see if this works. So here's what we're going to do. We're going to just try. I mean, worst case, I erase it and burn a bunch of time. That's okay. We're going to use y or y null. We use it loosely. Equals E. I'm not going to use A because we've used A to represent something else. Our text and a common letter to use is S. So how about we just call it E to the S? Try that. Okay, I'm going to try that for my null solution. I've got a y. I need a y double prime. But to get there, I'm going to have to go through y prime. So let's do that. So what else do we get? So we have y double, y prime. That's a single one. Y prime is going to be S. E to the S T. And what else? And y. I'm not going to write this n here each time, so we're just going to, this is all applying to this solution. So y is equal to, or y double prime is equal to s squared E S T. Okay. Let's substitute our trial back into the original equation, and let's see what we get. Let's see what happens. So this is going to give me m times s squared E S T plus k times E S T equals 0. You could go about this. We've been kind of dividing and canceling. I don't always think that's the right thought process. It really might be a cleaner way of thinking of this is if you write this as ms squared plus k, that whole quantity, times e to the st is equal to 0. Okay. Usually you would say that e to the st is not 0. At least at this point we would assume that. So if you were just solving a simple quadratic function where you had something times something equals 0, what does this imply? It implies that at least one of those factors has to be 0. This is the factor that we're interested in. This is the factor that will solve x. So let's do that. So let's solve for x. I'm not fine. Let's do solve. Solve for x. So I do that with m s squared plus k equals 0. Let's see, let's subtract the k, divide by the m. So I have s squared is minus k over m. Does that look right? Did I do that right? That's a problem. K is positive. X has to be positive. Marceline? I'm sorry. Oh, from the second derivative.
But that's squared on that.
Oh, SS. That's S squared. Interesting. Thank you. I see where. Thank you. I didn't even see that. All right. So if we solve this, this is always a negative. If we solve this, we have S is equal to. I'm going to write it as plus or minus square root. Oh, no, only a little bit of space in. Plus or minus, this is going to be the square root of k over m. Where'd the minus sign go? It's the square root of a negative that gives us an I. And that's how the solution comes into play. So see that the beauty of this is trusting the math, and it'll tell you what you need to do. So, let's do that. Let's write our solution. Okay, so our solution is this. Oh, yeah, go ahead.
Okay, so the reason that this is working is because when we were up there and we said, oh, one of these factors has to equal 0, even the ST boundary is 0.
It could, well, at that point, no. At that point, it's not. It's always positive. But remember, if E is written as an imaginary number, it's cosines and sines, so there could be a 0 in there somehow. But we're just assuming that this factor has to be 0. That's one of our possible answers. And when this answer is 0, is going to give us a value for x.
Yeah, okay, I think it makes sense. Well, because if we could assume that e to the ST equals 0, then we wouldn't know for sure that the other factor equals 0.
Right.
But because e to the ST can never equal 0 without imaginary numbers, then that other factor is equal 0.
Right. Okay. Oh, before we go on, this square root of k over m is going to come up now for the rest of this section. And so that's kind of ugly to work with. So usually the normal convention would be that you would write this as plus or minus I, and then we use omega. Does that seem familiar? Yes, so in other words, we're letting omega equal the square root of k over m. All right, so I'm going to use omega. Yeah. Question? All right, let's try this. So I have y is equal. So this is my solution. Is y is equal to. Wait, hold on a second. How many solutions is that? Yeah, that's 2 solutions. That's 2 solutions. So what we do then is our y null, I'll write that here, is going to be, it's going to be some constant, we'll call it C1 times e to the I omega t plus some other constant, we'll call it C2 times the I omega negative I omega. Clever, huh? So don't worry, we're going to check initial conditions, and we're going to solve that. But what we want to do is, now let's apply Euler's famous identity, and that says that y null is equal to C1 times, and I'm going to write this out, this is a cosine of omega t plus I sine omega t plus C2 cosine omega t oh, whoops. Darn it. Remember, this is a negative omega t now. So this is cosine of minus omega t plus I sine parentheses minus omega parentheses. Okay, let's regroup these. And we're going to, I'll even write this, is we're going to regroup, and I'm going to do this all in one big step. I know we can do this, we put our minds to it. Regroup I cosine, no, let's not, I want to do one more thing. Sorry. What was it, a hard one?
I don't think for you. So I understand here we're using Euler's formula. There to there, he explains that jump from S equals back to 1 and
Yeah, okay, so you're saying why do we have a plus, like we have two solutions there? From like from here?
Yeah.
To there?
Yeah.
Okay, good. Let's see if we can do this. So, remember the null is always a family of solutions. It's a scalar times whatever your solution is. So, what we did is we went back to this. This was our original solution. So I substituted x in there. And it turns out that I didn't just get one solution. I got two. This is one solution here. And then I got another solution. But as long as you just let these be, each one of these be a family of solutions, then what we're going to do is we can just add them together. And we can change these based on our initial conditions. So we had to account for having both solutions. You can't just take the negative one out like we have done and like we like to. We use the Pythagorean theorem. Yeah, like the y null plus the y particular. So now we just have two null solutions. So now we're just adding those two null solutions together. If we substitute those back in, they should give us 0. Each one should give us 0. If I put back, so what you would, let's check. I'll show you. So remember, if this was our solution, you could always check. This is a good question. So we'll do that over here.
The confusion is less on like why that is a solution. I think that we do have two solutions and each one can solve it. But why can we just say if this is a solution and this is a solution, then that is the same as if you add those two together and say, bam, it's also a solution. You're saying that adding the two solutions together is also a solution.
Yeah, if they're both 0. It's just like adding y null and y particular. Now I just have two solutions for y null. I will have 0 plus 0. Right, because you just want one simple solution. Let me think about that for a second. See if I have a better. Maybe an example would work. Watch. So let's just say for a moment, the only solution I had was this. Yeah, let's just say I only had one answer. That. Okay. So then this would be my solution right there. If I expanded it out, how many purposes it have? 2 parts, right? So you're like, okay, let's just see if these work. So what you could do is, if I was to pick, well, in the earlier solutions we said, well, I just want the real component of it, right? So let's just see what happens if I pick this is the real component. So I'm going to do this. So let's do, let's just try y0 as some C1 cosine of omega t. If I do that, then I would need y null prime. So that's going to be minus omega C1 sine omega t. And then y double prime is going to be minus omega squared C1 cosine of omega t. And so let's see. If I want to substitute these back in, I would have m times minus omega squared C1 cosine of omega t plus k times, or we're going to have to unravel these square roots. That's all right. K times C1 cosine omega t. So let's see what happens here. Let's try this. M times minus, well, omega squared is the square root of k over m. So if I square it, this is just going to be minus k over m. Oh, there's the solution. See it? C1 cosine omega t plus k C1 cosine omega t. Wait a minute, that's a k times C1. That's a minus k times C1, and the answer is 0. So you're like, wait a minute, which solution should I pick? Which solution should I pick? What about this? So this is kind of a strange idea. What's the imaginary part of this solution? It's sine omega t, right? But sine omega t is being multiplied by I. So that's the complex part of the number. But do you remember what we said about complex numbers? We said that these coefficients are real values, or in this case, a real valued function. So that would lead to, well, sine of omega t is a real valued function. Would that work as a solution? Let's try. Let's try. Let's try.